higher static routes, objects with compile time constant addresses. It's a new article in V8 dev blog. It was published by February 2024, and it's tagged with JS. Did you ever wonder where undefined true and other core JS objects come from? These objects are the atoms of any user-defined object and need to be there first. V8 calls them immovable, immutable rules, and they live in their own heap, the read-only heap. As an example, consider the extremely common isUndefined API function. Instead of having to look up the addresses of the undefined object. For reference, what if we could simply check even if an object's pointer ends in, say, 0x61 to know if it's undefined? This is exactly what the V8 static roots feature achieves. This was the source of hard tests they had to take to get there. The feature landed in from 1.1.1 and brought performance benefits across the whole VM, particularly speeding up C++ code and built-in functions. So, let's proceed to bootstrapping the read-only heap. Creating the read-only objects takes some time, so V8 creates them at compile time. To compile V8, first the minimum proto V8 binary called makeSnapshot is compiled. This one creates all the shared read-only objects, as well as the native code of built-in functions, and writes them into a snapshot. Then the actual V8 binary is compiled and bundled with the snapshot. To start V8, the snapshot is loaded into memory, and we can immediately start using its content. The following diagram shows the simplified build process for the standalone V8 binary. I should explain that V8 is a minimal debug V8 instance. Instance for debugging and developing with V8 engine. So we have a V8 source, which is compiled to live V8, and we have to pass it first if we have a snapshot. We proceed to V8, and if we don't have we should go and then make snapshot, then load the snapshot, and then run V8. Once V8 is up and running all the read-only objects, have their fixed place in memory and never move, when we G-code, we can AG directly refer to undefined by its addresses. However, when building the snapshot and when compiling the C++ for live V8, the addresses is not known yet. It depends on two things: unknown at build time first, the binary layout of the read-only heap, and second, where in the memory space that read-only heap is located. So, binary layout of the read-only heap, and where in the memory space that read-only heap is located. And how to predict addresses. V8 uses pointer compression instead of full 64-bit addresses. They refer to objects by a 32-bit offset into a 4 GB region of memory. For many operations such as property levels or comparisons, the 32-bit offset into that cache is all that is needed to uniquely identify an object. Therefore, our second problem, not knowing where in the memory space the read-only heap is placed. It's not actually a problem, because we can simply place the read-only heap at the start of every pointer compression cache without giving it a known location. For instance, of all objects in V8's heap, undefined always has the smallest compressed addresses, starting at 0x61 bytes. That's how we know that if they lower 32 bits of any JS objects, full addresses are 0x61. And then it must be undefined. This is already useful, but we wanna be able to use these addresses in the snapshot, and in V8 a similarly circular problem. However, if we ensure that makeSnapshot deterministically creates a bit identical read-only heap, then we can reuse these addresses across builds. To use them in V8, it's only basically build V8 twice. If you start from V8-C, we have two different passes. So first we can call V8, then make snapshot and generate static routes, and proceed to static routes H and load V8. And the second, we also have two different ways. From V8, go to make snapshot and snapshot without generating static routes. And another way is proceed to D8 if we have a make snapshot. The first time run calling make snapshot the only artifact produced is a file that contains the addresses relative to the cache base of every object in the read-only heap. In the second stage of the build, we compile the V8 again, and the flag ensures that whenever we refer to undefined, we literally use cache base plus static root key undefined instead. The static offset of undefined, of course, being defined in the static root H file. In many cases, this will allow the C++ compiler creating the V8 and the built-in compiler and make snapshot to create much more efficient code, as the alternative is to always load the addresses from a global array of root objects. We end up with a DA binary where the compressed addresses of undefined is hard-coded to be 0x61. Well, normally this is how everything works, but practically we only build V8 once. Ain't nobody got time for this. This generated static root H file is cached in the source repository and only needs to be recreated if we change the layout of the read-only heap. And further applications. Speaking of practicalities, static roots enable even more optimizations. For instance, we have scenes group common objects together, allowing us to implement some operations as range checks over the addresses. For instance, altering maps, i.e. the hidden class meta objects describing the layout of different string types, are next to each other. Hence, an object is a string if its map has compressed addresses between 0xdd and 0x49d. Or trusted objects must have an addresses that is at least 0xc1. Not everything is about the performance of GTD code in V8. As this project has shown, a relatively small change to C++ code can have significant impact to it. For instance, we don't draw a benchmark which exercises the V8 API and the interaction between V8 and its embedded, gain about 1% score on an M1 CPU thanks to static routes. So it's not representative because speedometer is only one benchmark and 1% is not too high, and M1 CPU is also not widespread CPU because we have Intel CPUs, AMD CPUs, CPUs on smartphones, and so on. And maybe 1% can be just an error, but if it's not only for M1 CPU, it's very good. Even 1% can be useful in performance. So thanks for watching. Bye.